Hello, everyone, and welcome to today's DigitalOcean Tech Talk. My name is Mike Metrell, and I'm an engineer at Pulumi. In today's talk, you're going to learn how to manage infrastructure, manage Kubernetes clusters and workloads in those clusters using programming languages on DigitalOcean. Before we get started, a couple of things to note. First, this talk is being recorded, so no worry if you're not watching it live. You can always refer to it after, because we're going to be sharing the video link in an email. And the video will also be posted to DigitalOcean's YouTube channel, as well as DigitalOcean's community's Tech Talks page. Also, in GoToWebinar, there's an option to drop questions in the questions box. So if you have any questions throughout the presentation, feel free to drop them in there, and we'll make sure we leave time at the end of the presentation to get to as many questions as we possibly can. No worries if we don't get to a response live, we'll make sure to get your response soon enough. So let's begin. So steering Kubernetes on DigitalOcean, what does this mean? How do we actually work with Kubernetes clusters? How do we work with infrastructure? And how can we leverage programming languages to improve our workflows and manage our stacks with more proficiency? Again, my name is Mike Metrell. I'm at Pulumi. You can follow us on Twitter at Pulumi Corp, or you can follow me on Twitter at Mike Metrell. To get things started, I want to get a gauge of the room. Many of you are visiting us remotely and digitally, and I would like to know, if possible, what your experience level with Kubernetes is, so I can gauge the talk appropriately to make sure that everyone can learn something from this talk. So if you'd be so kind and participate, just pull out your cell phone or pull out a browser tab and just visit the URL at the top, pulev.com/Mike Metrell 075, and just answer the simple question, how long have you worked with Kubernetes? That'll help me gauge how I can appropriately fit the talk so that everyone learns something. We'll leave it about a minute or so folks can chime in, but please take this time to do this, and I promise this is the only work I will make you do this today. I'll put the feedback results here live for those folks who are actually participating. Not everyone jump at once. Okay, great. We have some polls coming in. Give it a couple more seconds for folks to get familiar with the page. Again, it's pulev.com/Mike Metrell 075. And it's just one simple question. Okay, wow. So the majority of you are brand new to Kubernetes, so welcome. Thanks for coming out and joining us and learning more about how you can work with Kubernetes and DigitalOcean. It seems we definitely have some folks who have been experienced and seasoned folks working with Kubernetes, so I promise you'll learn something too, so need not worry. Great, thanks for your participation. That's all I need from you, so let's begin. What can you expect in today's talk? We're going to review what Pulumi is and how it works. Then we're going to show Pulumi in action by deploying a couple of droplet virtual machines on DigitalOcean using the Python programming language. Then we'll visit how you can do production Kubernetes architecture and how Pulumi works with that Kubernetes model. We'll show how you can deploy Kubernetes clusters, whether they be managed or self-managed, and you can deploy workloads into those clusters, and we'll do that using the TypeScript language. And then we'll show another demo of how you can do integration testing using the Go language on the demos that we'll be walking through throughout this talk. And then we'll leave time at the end for Q&A. So you'll learn how to manage infrastructure, you'll learn how to work with Kubernetes clusters, with workloads, and leverage programming languages to really manage the infrastructure in a better way than hopefully you've been doing it today. So what is Pulumi? Pulumi is modern infrastructure as code. What does that mean? It is a tool that allows you to provision and manage cloud-native resources using your favorite programming languages. Pulumi supports languages JavaScript, TypeScript, Python, Go, and the .NET family. That means you can use these languages to provision all resources that you can imagine for public cloud providers or on-prem situations. So here's an example on the right. Here's a snippet of what it would look like to create a DigitalOcean domain using the TypeScript language and the Pulumi libraries. So because I'm using programming languages, I'm able to use my usual IDE flow. I can import the SDK, in this case, the Pulumi DigitalOcean package that I'm pulling from the NPM repository since I'm using TypeScript. I can define my DigitalOcean domain, give it a name, give it an IP address, and then I can optionally export properties on that domain if I wish to share that resource with other Pulumi programs or other users. So immediately I have the ability to have an IDE to help me to compile against a known spec, to do checking of spec matching, to do linting, to do IDE integration to jump to documentation, and more importantly, to do testing, right? So this allows me to leverage programming languages for this very appropriate task. So why are programming languages so important? Well, the current state of art of tools today in infrastructure code are ones like Chef and Puppet and Ansible and Terraform, or orchestration templates for that matter. And these tools have served folks very, very well, but they leave a couple of gaps as you begin to grow. A bucket of those gaps is essentially some of these tools will directly modify state on a machine as opposed to modifying state in a given system, like an API. When you modify state directly on a machine, that doesn't prevent anybody else from making the same changes in that machine. And so you don't really have a good understanding of what that machine should look like and how it should function. Whereas an API system, because it's a program, you can manipulate its state appropriately and you can set it to the configurations that you need. And if folks are to deviate that state, you have a state of the world, as we described in our program, to say, this is what the state of the world should be. So if I had, say, one virtual machine and someone went on and created 2 more additionally virtual machines, the next time I can refresh and we can reconcile all of these changes and make sure there's only one virtual machine, because that's what I've been describing in my program. Because it's code, I can leverage the same package managers and sharing functionality that I have today. So if I'm using TypeScript, I'm using NPM. If I'm using Python, I'm using pip. If I'm using Go, I'm using the Go modules from GitHub or any other version control system that you use. And if I'm using .NET, I can use the .NET dependency packages like NuGet. So with this code, you will allow yourself to preview these changes before they happen, because Pulumi can see each property at its most finite state and see what's changing and whether it can change or not. Because it's code, you have a full audit of who changed what when. If you integrate this with your GitOps pipeline, your CI/CD pipelines, you can preview these changes, you can approve these changes, and you can roll these changes out. Pulumi has integration with secrets management as a first-class resource into the program, because it allows you to not only maintain the sensitivity of information like database secrets in your stack, it allows you to make sure the whole stack is protected as you see fit. But Pulumi isn't just about provisioning cloud-native infrastructure like VMs and block storage and virtual networks. It also has the ability to test your infrastructure. So you can use a language like Go to test and validate through unit testing, through integration testing, the stacks that you're provisioning are functioning in the way that you expect them to. And most importantly, Pulumi's SDKs are open source. We're Apache 2 based, and we have a great SaaS and console that works with our CLI tool for both individuals and teams. And for teams, we have the ability for you to enforce and optimize organizational policies that everyone must adhere to for your infrastructure and how they manage that infrastructure. But Pulumi isn't just about cloud native infrastructure as code, it's about Kubernetes as code too. What we mean here is that you can use Pulumi to not only provision the infrastructure such as VMs and virtual networks, you can also use Pulumi to provision managed Kubernetes clusters like the ones that DigitalOcean offers, or the raw compute if you want to build the Kubernetes cluster yourself. So you can use languages to manage the cluster, but you can also use the languages of TypeScript, JavaScript, Python, Go, and .NET to provision the Kubernetes API resources that you may be familiar working with, such as a Kubernetes deployment, a Kubernetes service, a Kubernetes config map. Because what we do is we take that same API, just like we do with all the cloud providers, and we expose it as a library SDK as noted above. And once we expose that as an SDK, you have a first-class construct in the language that can guide you against a given spec that we can compile against, that we can test, that we can readily build out without seeing any obvious changes, because the compiler will tell us if something's wrong. If you've used tools in the past, you've noticed that when you configure things like YAML and JSON, typos and errors aren't discovered until deployment time or much later, and they tend to be fairly nuanced. So languages allow you to bubble up that much sooner and get a better handle of it. And because you have type systems in some of these languages, you can enforce that the spec that you're working with is compatible as the provider expects it to be. So here's an example of a snippet of how you can use TypeScript to create a Kubernetes deployment and a Kubernetes service. So I'll review what the Pulumi config system is, but I can import the Pulumi config that allows me to parameterize the settings of this particular program. I can create a provider, which is just a wrapper around the credentials to access my Kubernetes cluster, in this case, kubeconfig, if you've worked with Kubernetes before. Once I have these credentials, I want to separate them out into a provider because I want to have the resources be independent of the credentials that created them. So that way, if I need to rotate these credentials or simply alter them, I can make sure that the resources are stood up with the appropriate credentials that I want them to be. So I can pass that provider into this object to create a new namespace. I can create a new pod for Nginx that I can deploy into that namespace. I can wrap it in deployment and say I want 2 copies of Nginx running at all times. And I want a public load balancer. I want a public load balancer that allows me to expose these virtual machines in a public way that gives me an endpoint that anyone can reach. And because it's code with Kubernetes, I can not only deploy the Kubernetes API resources that the API system supports, you can also deploy Helm charts directly. You can deploy YAML manifests if you still have those. You can inject sidecars like Envoy or Istio or Prometheus, depending on what it is you want to configure. And because we are a CLI tool, we have many integration points with our great CI/CD partners. Because we are a CLI tool and no one's workflow is the same, no developer, no operators work in the same fashion, we have many integration points to support your workflows. We support various source code integration providers with companies like GitHub and Bitbucket and GitLab. As we said earlier, you can use the languages JavaScript, TypeScript, Python, Go, and .NET with Pulumi to author and manage your infrastructure. Your applications can remain in whatever language they're already in. You can just port them over. This is essentially just talking about the infrastructure aspects of it. To work with the code base, depending on the language of your choice or the platform of your choice, you can use package managers that you're already familiar working with. So if you're in the Node family, you're using NPM. If you're in the Python family, you're using pip. Similarly, we have integration with other CI/CD partners, such as Spinnaker, CircleCI, GitHub, and Travis CI. We support many different environments, both public providers and private, and we have the ability to integrate with Kubernetes in a very first-class way. On the bottom, you'll see a couple of screenshots of what our console looks like when you work with Pulumi. You can get a rich preview directly in the pull request embedded so you can approve or deny whether these changes can actually be rolled out. In the middle, you see a full audit timeline of who changed what when, on what commit, in what branch, and did that succeed or fail. And then you can have a laundry list of resources that are being provisioned in this program, so you can do a fine-grained detail of the cluster and the resources that I'm creating and see all the properties in a very consumable format. How does the Pulumi CLI work? So first off, you author a program, such as creating a DigitalOcean domain in the language of your choice, say Python. The Pulumi CLI will parse that. All of this is happening in your client. We don't see any of this on the Pulumi side of things. Once it processes your program, it'll invoke the runtime that you've chosen. So if you're using Python, it'll invoke Python. And once you describe those resources, it'll go off and directly make an API request to the provider of your choice, in this case, DigitalOcean. So it'll say, create me a new domain in DigitalOcean, and it'll make that API request directly. There is no interchange format. There's no conversion to JSON. There's no conversion to YAML. Your program is the desired state. What you write in that program is what it will be provisioned, and that's what it will maintain as far as provisioning goes. So you can work safely knowing that when you create your infrastructure, what we are doing is actually building you out a graph of the different components that your infrastructure has, and it's basically creating a sequence of the order that they should be stood up so that way they can all be created appropriately. This never leaves your client machine, but this graph gets ultimately stored as a state file. And this file is what says, this is what my stack should look like. We do some checkpointing by default in our Pulumi SaaS that's free for individuals, and it has different tiers for teams. And in that SaaS, you can checkpoint that file. You can do concurrency locking. So if you're on a distributed team working on a similar stack, you're not stomping over each other's changes. We have integration with things like identity and single sign-on. And we have this ability to integrate with configuration systems and secret systems so you can leverage those in your stacks as well. A Pulumi project is no more than a directory that has a Pulumi program, a metadata file so the Pulumi CLI knows it's a Pulumi program, and then the dependencies that your program needs, such as the Pulumi DigitalOcean library. You can take a Pulumi program and instantiate different copies of it. What that means is I can reuse the same infrastructure over and over again, but I can change parameters depending on the environment that I'm running in or depending on the branch that I'm working in, such as if I have 3 different phases of development, staging, and prod, I can have different number of VMs that I want to say schedule. Schedule 1 VM for a developer, 2 VMs for staging, and 3 VMs for prod. I can configure that using the same program without having to copy and paste this over and over again. So stacks give us a great way to instantiate a given program and change the parameters as we see fit. In Pulumi, stacks can reference other stacks. So you can imagine if there's 2 Pulumi programs, if I am the identity team at my company, and I wrote a TypeScript program on the left. And my colleague is an application developer writing his infrastructure, such as his VMs, in Python. My colleague can reference all the outputs that I want to make available for them, such as, say, the ID of the VPC they have to work in, or the API token they have to use. And they can mix and match the pieces that they need, but you can segment these responsibilities by the organization, by the roles, and by really the function of what folks should and shouldn't be doing. So this gives you a great way to break up your infrastructure and make it more composable depending on how you manage your infrastructure and how you organize your teams. But Pulumi programs are really all-encompassing. The provider allows you to instantiate the infrastructure, and Pulumi can be scripted to write anything that you want. So you can create a Pulumi program that has VMs or object storage or block storage, or you can provisioning a Kubernetes cluster or a virtual network. And all that essentially will be a set of resources that we map out in order and create in order to make sure that we're meeting the infrastructure that you've programmed. The output of that is this graph that we store as a state file. And that state file is what regulates what the view of the world should be for your stack. So if anyone fidgets with that, we can refresh and get the changes and try to enforce the state to make sure that we always have the state that we expect. Let's jump into a demo of how Pulumi works in action by using droplets on DigitalOcean. So I'm going to switch my screen real quick. So here we have, on the left, a Pulumi program that's written in Python. And on the right is going to be our ability to control this program through Pulumi. So the left is a Python program that describes the following. We're going to deploy a stack that has 3 droplet virtual machines, and these virtual machines will be put behind a load balancer that we will publicly expose. So if you've written Python, this is regular Python. I have my IDE. I have the ability to have my compiler yell at me if I, for example, am not following the proper casing that I expect. But when I change things like essentially, what am I doing here? I can delete state, and I can say if I have a typo for a variable that doesn't exist, I can have my IDE tell me, hey, this change is not going to work. So I want to make sure that at compile time, I fix this so that way the deployment actually functions. So languages allow me to catch these changes early on and to improve the workflow that I'm authoring these programs in. So I'll set an account and say, I'm going to spin up 3 virtual machines. I'm going to reach into the config system of Pulumi and get the region. What does that mean? Let's switch over to the right. So I have the program, and remember, we create stacks or instances of this program. So the first step I'll do is do a Pulumi stack init. I'll give it a name dev, and because it's Python, I have a requirements.txt. I'm going to install those requirements in my virtual environment. Great. And I'm going to do some configuration settings, such as give it the parameters that I want to set to this particular program. An example of that is the region. So let's say I want to deploy this program of virtual droplets into the New York City data center that DigitalOcean has. Similarly, I will do some more config to set up my DigitalOcean token so I can provision in my account. As you see, I can set secrets on configuration values that mask this value and actually encrypt it in the state, whether I use encryption that is ciphertext by default in Pulumi, or a given key management system key that I can use to lock that if I need to. So this configuration management system allows me to tap in the program and get that value accordingly so I can use it in my program. With the region pulled out from the config system, I said, I'm going to create a user data script that allows me to update the packages on boot and install Nginx. And we're going to throw these 3 copies into a for loop. So I say for up to 3 droplets, we're going to create 3 virtual machines of type Ubuntu with ½ gig of RAM in this particular region and with these tags. Once that is provisioned, I'm going to create a load balancer that sits on top of these VMs and round robins between each of the virtual machines while exposing a public load balancer. So let's see what this looks like in practice. So I can see that with Pulumi, I can do a preview to see what does my changes look like before I deploy them. I can see, oh, great, I'm going to create 9 different resources. Some of these are droplets, some of these are tags, and then we have the load balancer. I can get a bit more rich of a diff if I pass it the flag, and I can see the actual details of these resources and their properties. So for example, I can see that this droplet is being stood up with an Ubuntu 20.04 image in New York City with 0.5 gig of RAM and this particular user data. Great. So if that all checks out, I can either approve this or deny it if you were in a pull request, for example. And if everything looks good, I can just run a Pulumi up to deploy those changes. So I'll say, yes, deploy the changes. This will take about a minute or so. But while we do that, let's kind of go back here and explore what it is that we're building again. So we are constructing 3 different virtual machines. I've been able to configure these parameters as I see appropriately. I can set some of this to be configured in the config system of Pulumi if I want to template this out across many different programs. And I have the ability to leverage languages to give me things like warnings when I say, hey, this user data doesn't conform to uppercase naming style. So if I say, I'm going to write this as it should be per my linter, those errors should go away. And they do. And so now my program looks completely fine. And that's the beauty of using programming languages over, say, using tools like that have YAML or JSON or domain-specific languages, because at some point, the functionality is limiting as far as what you can and can't do. And we already have all of these problems solved for us but with programming languages, because we have IDEs, we have linters, we have checking. And so we should be able to leverage those tools, not just for applications, but for our infrastructure as well. All right, great. Our deployment on the right has finished. So let's actually go and visit this URL. Let me share my desktop to get a little bit more of a bigger view. And in this screen, we're going to visit the page. So sure enough, if I hit that endpoint, I'm getting Nginx. Great. So the cool thing that folks can see is that I deployed these changes. Now, if I want to say make a couple more changes and say spin up one more droplet, I can do a Pulumi preview and see that it's going to say, you want to stand up one more virtual machine. Great. So it's going to create that along with this tag. So if I do a Pulumi Refresh, remember, a Pulumi Refresh is fetching the states from DigitalOcean. So once I created the virtual machines, there may be metadata or timestamps or information that I don't know about before it's been deployed that gets added after the fact. Pulumi Refresh allows us to reconcile the states between what I have in my program and what exists in DigitalOcean. So when I do a Pulumi Refresh, it'll tell me, hey, there's some information here that's been updated that your program's local state does not have. Well, what are those details? I can see that I've never specified an SSH key and that the total resource count here I have is 3 replicas for my droplets. So I'll say, yes, refresh these changes. If I do a Pulumi preview, I can see that I have the ability to create that. And I'm going to do a Pulumi up, yes. And it'll go off and change that. So once that gets stood up, another interesting property to note is that you can mangle this however you see fit, but you are ultimately going to dictate what gets into the state of the world by what's written in this program. So just as we change the parameters here, anything you change on Pulumi, as far as the code goes, is going to be reflected the next time you roll an update. So soon enough, this will finish, and we have now, if I spec Pulumi stack, I now see I have 4 virtual machines as I expect them. Awesome. I'm going to destroy this and move on to the rest of their demo. So with that kind of setting the stage, right, we now want to talk about Kubernetes. So Kubernetes is a very multi-layered approach as far as how you want to work with Kubernetes. There's different layers to go about it. And the way Pulumi works with Kubernetes is by offering many different library packages that allow you to encapsulate, configure, and manage each of these layers. At the very bottom, bottom 2 rows, you essentially have the core infrastructure providers that give you the resources and infrastructure to provision things like virtual machines, virtual networks, storage, and keys. Most of these providers have a managed Kubernetes offering that allows you to actually deploy a Kubernetes cluster, manage that cluster if you want to do it yourself, and then once you have a cluster up and running, you're left with an empty kind of vanilla Kubernetes cluster. And now the work really begins for you to turn that into something that you want to use, to install the services for the cluster and applications that you may need, and then finally deploy the applications on top. As noted by the markers on the left and right, you can see the different SDK packages that Pulumi makes available across all of our languages: TypeScript, JavaScript, Python, in Go and .NET that allow you to work with the infrastructure side of the things, as well as the application portions of Kubernetes. So with Kubernetes in particular, you can create Kubernetes API resources using the Pulumi Kubernetes library and the Kubernetes X library. Let's show a demo of how we can use Kubernetes clusters in TypeScript. So we'll switch to our second screen here. And what I'm going to do is I'm going to kick this off. I'm going to, as I walk you through the example, I'm just going to deploy this. We're going to deploy a cluster, and we're going to just leave this running in the background. And for the sake of time, I'm going to run this test as well that I'll get to in a sec. So on our left, we have a similar program. This time we have it in TypeScript. Remember, we were doing Python before. So now we're switching context and we're using TypeScript to author a Kubernetes cluster on DigitalOcean. So since I'm using TypeScript, I'm going to pull my packages from NPM. These packages are DigitalOcean to configure DigitalOcean resources. This is Kubernetes to deploy Kubernetes resources into that cluster once it's up, and some facility functions that allow me to work with my cluster in an easier way. So I can leverage the config system in a couple of different ways here. I can say, hey, because I want to deploy a Kubernetes cluster with a given API token, for those of you who don't know, Kubernetes clusters on DigitalOcean have the ability to provision an API token for you on your behalf. I decided I wanted to control this API token myself, since I can revoke that token whenever I see fit, and because it allows me to have better control of that token if something were to change. So I'll pull that token in from the config system, and I'll also use it to get some defaults. So a Kubernetes cluster is essentially a control plane that the provider is running for you, and a set of nodes that deploy your workloads. In these nodes, I can say either get a configuration number that the user has specified, or if not, default to 1 copy. Similarly, how many copies of Nginx do you want running on this cluster? If the user does not specify, I can default to 1. But we can already see how languages here are beneficial, because I can not only do this sort of logic, I can see if I do like a button in F6, I can see the whole type of this actual value of this variable. And I can make sure that at deployment time, these specs are interoperable because the types match. Similarly, if I want to, I can jump into defining a Kubernetes cluster in DigitalOcean by saying, here, use the region that the user has specified. We're going to deploy 1.17 of Kubernetes, and we're going to create a node pool that's attached to this cluster. We're using a droplet that has 2 vCPUs and 2 gigs of RAM with the count that we specified of 1 node. Once that cluster comes up, we can actually pull information out of that cluster, such as its name and the kubeconfig that comes created with it, so we can access the cluster. But because I have languages, I can do things like jumping into the documentation. So I can see that if I don't know what I'm building here, I can see that the arguments to create a Kubernetes cluster in DigitalOcean are encompassed in this type called Kubernetes cluster args that takes a name, a node pool, region, tags, and I have all this documentation to refer to not only know how I can work with this in my IDE, but I can have types that validate that the variables are holding the values that they should be having. So I can leverage languages and IDEs far better than I can YAML or JSON for that matter. I can go back to my code and continue to see that I'm going to provision a cluster, and then once the clusters comes up, what we're going to do is we're going to create our own kubeconfig file using the API token. So again, because DigitalOcean has this API token by default that gets provisioned with clusters, I wanted to take the extra measure of making sure that I provide my own token, and then I can have a kubeconfig file that uses that token to access the cluster. I'll pass that into what's known as a Kubernetes provider. Again, this provider is this notion of it's the ability to decouple your resource from the credentials that instantiated them. So if you need to swap those credentials out, or if you rather do it with another user, you have that leverage. So with that provider, which is essentially just a wrapper around the kubeconfig that we created above, again, we can reference objects here. So that's the other benefit of using languages. We're not referencing strings that are hard-coded in like JSON or YAML or domain-specific languages. We have symbolic objects that we can reference because it is a programming language. So we can reference these objects, we can access properties of those objects, and we can manipulate it as we see fit because it's just code. With the cluster finally deployed, what we're going to do next is create a deployment in Kubernetes, which is just a spec of a set of given pods. And these pods are going to essentially spin up an Nginx application with a number of replicas that we've given it. It's going to select on a subset of labels that we've provided. And once that deployment is up and running, we're going to attach a Kubernetes service. And this Kubernetes service is going to expose that Nginx deployment to the public world using a publicly typed load balancer. We'll say that on this load balancer, we're also going to target the same labels that we're using to target in the deployment. So we know we're selecting a particular set of workloads. And with that, we can say, open up port 80, so that way when you provision the infrastructure and provision the load balancer, you can forward port 80 onto the Nginx app itself. Because these are resources, I can now reach in and get values that I may want, such as I can reach into the service that in Kubernetes for this Nginx app. I can retrieve its status, reach into its load balancer, and pull out the IP that gives me the ability to have ingress into this load balancer. So I can take that public IP and I can do things like create a vanity URL where I can interpolate some string with the prefix that I need with the IP, and I can create that and expose it for folks who want to consume that in either other Pulumi programs or other users who want to actually reference this or access those endpoints if they want. So we'll give this a couple of more seconds because this should be finishing up soon enough. But the one thing that I want to call out here is you have the ability to describe infrastructure in a more robust way. As your infrastructure scales, as your complexity scales, this becomes unwieldy if you don't have programming languages, because ultimately everyone's workflow is different, everyone's requirements and standards are different to run these applications in production. So ultimately you need something like a complete programming language to encapsulate the expressiveness that you want to encode. As this finishes wrapping up on the right, I'm going to switch context just for a split second and show you what it looks like once we are actually up. So on the right, it'll be done just shortly. I can show you that if I check out what this is actually doing for me, I can see that in this provider, if I do a Pulumi stack, I can see that my stack is still being provisioned. It started 6 minutes ago. I can see resources. I can view this on my console. So in the Pulumi console, I can view what resources are being stood up. So here I have a full view of the console of who owns what as far as the metadata for this project, what activity has been taking place. In this case, I can see that a deployment has been stood up, and I can see that the information there is still refreshing because we're rolling out the update. The timeline says here's the given commit on the given branch. And as these start to become more fleshed out, I can see these provider resources become more flourished in the stack once the deployment actually occurs. So this will keep going. And while that's going, I'm going to switch back to the slides and talk to how you can test your infrastructure in Pulumi. Testing is a key fact that many people don't really think about when provisioning and managing infrastructure. Most folks pretty much stop at how do I get things up readily and how do I actually work with it? But it's about policies. It's about making sure that you can test this infrastructure, that you can readily work with it. And one of the cool things that Pulumi offers you is the ability to do just that. So I'm going to show you what it looks like to do something a little bit more advanced before I show you a test in Pulumi. So we have a great tutorial that our friends at DigitalOcean put together that is located right here in this tutorial that allows you to take the recommended steps to secure your DigitalOcean cluster by opening up your cluster to other users by creating client certificates. Once you create client certificates for like a group of users, like say developers, you're allowing yourself to use credentials to rectify and validate that you can actually authenticate into the cluster. But as you can see in the documentation, we have to do some manual work around creating the certificates, invoking those certificates, passing those certificates to Kubernetes to approve and give us a client cert for the request that we've issued it. And once that's up, we can actually set up then the access authorization aspects in Kubernetes, because accessing the cluster is the authentication piece. The next step is the authorization piece. What can the developer users actually do in these clusters? And that is defining different settings through RBAC, role-based access control, on the properties that they can use in Kubernetes, what they can't use, and how they can use it. So what we've done is we've taken this tutorial and we've codified it into a repeatable program that you all can use with, at the end of this talk, I'll share the link. but you have the ability to take this full tutorial and never really have to worry about it again, because we've been able to codify that in a program using Pulumi. So what that means is here, I have changed now this update to say, I'm going to also create a new client certificate request with a given key. I just generate this using OpenSSL. And I'm going to create a client cert in Kubernetes that will be approved by the cluster for me to use for my developers. I can jump into that code and see that what it's actually doing is reading a couple of files, forming this certificate, this client certificate request, issuing that certificate request to Kubernetes, and once it's been retrieved back and improved, write it to a local file so I can consume it. That gives me the access credentials for the client. I'm going to similarly wrap that in a provider so I can go off and use that provider and now deploy something as this developer group using the client certificates. This allows me to create a namespace as a developer, because I can create a namespace, as an admin, and then the developer can actually create the resources after we've given them roles and access control into that namespace. So if I go to that, I can see that this particular role is only going to be allowed to use the following resources: config maps, pods, secrets, deployments, and they can only do the following verbs: get, list, watch, create, patch, update, etc. And so that allows you to gate what they can do, how they can do it, and how much freedom they have to work within the Kubernetes cluster. This gives us more security, it gives us limited privilege, and similarly, it's not just about reducing the scope at which users can operate, it's also about enforcing things like a quota, making sure that they have boundaries to how many compute resources they can use, how many compute resources their containers can actually take up. And you can even enforce things like limits and ranges that allow you to actually enforce these limits on a hard way, so that way they don't get scheduled if you know you don't want applications that are heavy in consumption of resources. Once that is up, we'll deploy an application as a developer that allows us to truly manage this in a programming first, cloud agnostic kind of way. So here you see I have this new class that I called a demo app. In this demo app, what I actually have is a class that essentially is an extension of what we call in Pulumi a component resource. This is a collection of resources that are managed together when you want to co-locate the responsibility of these applications. So what's a good example of this? I want to create an application that I have locally, which is a Node app. This Node app looks like the following. It is a simple server in JavaScript that says, listen on port 80, expose the root path to this index HTML, which is just simply a hello world file. And once that's running, make sure that that container can actually serve that response. In that, I can then use the latest feature, for example, at DigitalOcean release, which is a container registry, to provision a registry in a single line of code. That's the power of programming languages. I can create resources like this very, very articulately, and I can even encompass them like I'm doing here in the demo application to really minimize the amount of work I need to think about if these things are supposed to be managed together. So just like I have a package in Pulumi to manage DigitalOcean and Kubernetes, I also have a package to manage Docker containers. So I can do a Docker image and do the Docker file, since I have a Docker file here for this app that simply just says, hey, give me a node runtime, set up some of the directories, copy the application that I just talked about for the hello world over into that container, run npm install to install the dependencies, and then actually run the Node app and serve it. In that, I can take that Docker file from Pulumi, build it in my program, and automatically push it up to the registry that we just created up here. So in 10 lines of code, I created registry, and I built my image and deployed it into that container registry. Similarly, if I'm working with Kubernetes, I can create configuration maps, secrets. I can even pull in all sorts of configurations, such as being able to describe a pod and wrap that pod in deployment using less code. As you see here, I'm using this new abstraction that Pulumi offers called Kubernetes. And this is essentially a subset of the code you need to write to actually work with Kubernetes. In that, you can see that if you want the full Kubernetes spec, we don't create new nouns, we don't create new verbs. We expose the full Kubernetes API for you and allow you to truly define this as you see fit. But where we think it makes sense, we want to reduce the boilerplate you need to author and to create and to manage all of these. So what happens is that you can create all of these resources for you by still being able to tap into the full API spec. So I can create a persistent volume claim just as I expected. The secret, if you're looking at this, if you've worked with Kubernetes before, if you have seen anything with Kubernetes before, a lot of this should look familiar, right? We're just doing it in the language of our choice. So we'll start with deployment. That deployment can be as verbose as we need it to be, but see how terse it is as far as how much information is required for us to set up. It's so much simpler if we could just reduce that boilerplate and only use the parts that we need. And here we've done it. In a couple of stanzas here, we've essentially replicated the same setup that we're identifying here using the full API spec. That allows you to not only manage your infrastructure and your clusters, but it allows you to start encapsulating and managing these clusters as artifacts that really are managed on their own. We're wrapping up on time, so I wanted to show you what it looks like to test on Pulumi using the Go testing framework. Here, we have a great slide that shows you that the examples that we just opened up, for example, running a droplet in Python, running Kubernetes clusters with developer authentication using client certs and some hardened security rules, we can test that using the Pulumi Go integration framework to validate that these stacks are coming up as we expect them to. So here's a Go test. If you've worked with Go test before, this should be fairly straightforward. This is a Go test file. I will use the same framework I'm used to working with here. I set up a couple of options that I've imported from the Pulumi integration module. It'll say, hey, create this load balancer with a given set of configuration settings. And after it's been stood up, make sure that the body that we extract from that endpoint matches Nginx. As we saw earlier, it says welcome to Nginx. So we can parse that file and assert that our stacks are coming up as we expect them to, and our applications are functional as we expect them to. So that's the droplets in Python. We can do the exact same thing to test Kubernetes clusters in Pulumi using the same framework. And in this case, we're using the ability to test this stack that has a Kubernetes cluster with lockdown developer users, with lockdown role properties as far as what resources they can use, a quota, a limit, to enforce really secure standards, hardened standards, because once you start working with Kubernetes, it's not just about getting your apps into these clusters, it's about sharing these apps, whether it be with other team members, with other users, or with other applications that you yourself are authoring. So you want to make sure that these boundaries are set. And you can test this similarly by deploying and pointing it to the stack program that we have here that we just went over, and verifying that these endpoints are actually returning the hello world that we were referring to in our previous Node app. We are coming up on time, so I want to open it up for questions, and I believe our friend Samantha should be joining us any second.
Thank you so much, Mike. Great job. And thank you everyone for asking some questions so far. If you have more questions, please type them in the questions box and we'll answer as many of them as we can live. So one person wrote, Mike, no question, but some praise. Awesome work on making the naming and API match the Kubernetes spec while also adding some nice shorthands. Cool stuff.
Thanks for that comment.
All right, I'll dive straight into it. Does Pulumi handle CRDs, custom resource definitions yet? They're a rapidly growing part of Kubernetes and are not well supported by many systems.
Great question. So for those who aren't familiar, CRDs, or custom resource definitions, are custom API types in Kubernetes. So Kubernetes has an API type like deployments, service, config maps, secrets. Those are known API types. Custom resource definitions are custom types that I want to encapsulate, say, like if I want to manage SQL by myself, if I want a Kafka operator, if I want a cert manager. These are all applications that have their own custom types. Yes, Pulumi supports custom resource definitions. So right now we actually have some great work that we're working through to harden these CRD types, because as you may be aware, if you work with CRDs, not all CRDs are built the same, not all the APIs are managed the same. So you can definitely author and create CRDs and the instantiations of those custom resources in Pulumi, but we're going to add more structure to harden the spec. Since all these custom resource definitions have custom specs, we want to be able to bubble up that spec into a first-class type in the language of your choice. So that work is ongoing, but yes, we support CRDs. Great question. Great.
Does Pulumi support or plan to support Java?
Great question. We've definitely had questions for that. We have some ideas on that front. Nothing that I can necessarily talk about at this moment, but we have gotten that question, as well as other languages that folks support. So thanks for that question. We hope we can address that soon enough.
What's your recommendation to avoid rebuilding Docker images between different stacks, which would happen with a native approach that creates VPC, registry, and cluster in one stack?
Yeah, great question. So the ultimate baseline for that is going to be, do you want to build it in Pulumi? Do you want this to be built centrally somewhere else, especially if it's being shared across stacks? And the decision really kind of depends on how your architecture flows. For the example that I showed here, it makes sense since I'm essentially operating on a single stack, I'm a single user, and it's probably not going to be shared. But as far as caching goes, that's going to be leveraged on the local machine, since all that Pulumi is doing is essentially calling out to the Docker CLI and doing that locally. If you're looking to use this across stacks and building it may be an issue, then it's maybe something you should think about centralizing either in a central stack that does the building for, say, children's stacks, or something more like in your CI/CD system that is more centralized but touches all of the programs that you may want to work with.
Cool. Can you create your own references for services that you do not offer, like zero tier, for example?
Yes, so we actually support dozens upon dozens of providers, and you can visit. So here are a couple of helpful links to get you started on Kubernetes on Pulumi, and all the code that I listed is in this third bullet in the repo. So please check that out. But yes, we have the notion to essentially take a provider that may exist. So you can think of Pulumi as this: it's an API of many APIs. So as long as there's a CRUD API interface, the work to expose it in Pulumi as a library is pretty minimal, and we can usually work with you to make that happen. So you can either do that yourself to make it a more first-class resource, or we have this notion of dynamic providers, which are essentially kind of this cross between not a fully embedded provider and not quite something that's being scripted. It's somewhere in the middle, where you can dynamically at runtime say, create a CRUD interface depending on the provider of your choice. And in this case, if you have an API like the zero tier you're mentioning, you can call out to that API and issue the commands that you see fit. So there's a couple of ways to go about it, absolutely.
What's the support for running Pulumi in an unmanaged fashion, like towards the lines of GitOps from something like a CI/CD system?
Yeah, great question. So a lot of the CLI commands that you saw me use, like Pulumi Preview, Pulumi Refresh, Pulumi Update, that is really the domain that you're going to be living in when working with Pulumi. Similarly, your CI/CD systems will do the same. We actually have a Docker container and some specialized Docker integration containers for things like GitHub, and we're looking at Circle CI as well, that allow us to drive the Pulumi CLI from your CI/CD, so you can preview these changes, see those changes get posted through a webhook in the pull request, so you can say, yep, thumbs up, thumbs down, these changes look good. And even on when you say you press that merge button, it'll actually do a Pulumi update. But the commands you're living in are essentially that: Pulumi Preview, Pulumi Refresh if things are changing and you want to make sure you have a good understanding of the current state is, and then Pulumi Update to actually invoke those changes.
Can you discuss using Pulumi to perform infrastructure testing, specifically using language testing libraries to check infra and compliance?
Yeah, so we actually have a great blog post. I don't have it linked here, but I can definitely add this after the fact. Let me actually show you this is probably more helpful. If you take a scan of that QR code, it'll go to this presentation slide deck and give you all of the access to the information that we have here. I will make sure to add something in there about language testing, but yes, we have a great blog post that covers how you can use things like Mocha to do unit testing and mocking to some degree. There is some nuances since you're working with infrastructure, and there's only so much you can really truly know in anticipation, especially if you're working with like a cloud provider, right? Mocks and unit tests can get you most of the way. But yes, for the most part, your usual development tools that you use for testing are applicable, and I'll drop a link into the helpful links on a blog post that covers the various use cases that you can do to leverage the tool sets that you currently have.
What are the best ways to embrace Kubernetes without having to change everything?
That is a great question. So Kubernetes is a very tall order of complexity if you want to look at it that way, but it's a great solution in the same sort of solve problems that we've all faced or been plagued with for many years, and that is reliability, robustness, and just the ability to programmatically orchestrate what our workloads should and shouldn't be doing. So I would say I always start small. The need for Kubernetes is something that you and your team and your organization are going to have to make. There's no one that's going to suggest if Kubernetes is the right thing that you should be using, but at the very least, start off with a single container. Take an application that you have that you're looking to, say, port to the cloud native world, to bring to Kubernetes, and isolate that into a container. That's step one. Get familiar with that process. Get familiar with the process of running that container on a single Docker host. The second you want to run multiple copies, the second you want to make sure that these things are fault tolerant, that they're highly available, you need to involve multiple Docker hosts or multiple hosts for that matter to run these containers. That's where something like Kubernetes really starts to fit the bill, depending on how much you want to take on, because Kubernetes allows you to script and manage all portions of your application, whether that be the application, the ingress, north and south traffic, east and west for service matches, configuration management, secrets, right? The list goes on. So you can configure as much as you want. I say start very small, single container, single host, get that container running, then get it as a deployment in a Kubernetes cluster in just that object, and do nothing else. Get familiar with using that. And once you get to that point, the needs that you yourself identify are only a matter of researching how you can do it in Kubernetes, because at this point, most use cases are solvable in Kubernetes for both stateless and stateful workloads. There are caveats, and there's always going to be pros and cons to approaches, but that is the best way I would recommend folks start off, because you should not jump into the deep end of the pool. Start small.
What options do we have in saving the Pulumi state other than the Pulumi web console?
Yes, so great question. So this state file, you can store locally on your local file system if you like. By default, we do it in the SaaS because it's easier for folks to get up and running, right? A lot of the pain points we heard is, this is great, I want to use an infrastructure as code tool, but I really work on a team, so I need to be able to share the state across multiple people. These people are distributed all over the world. So we made it easier to make sure that that state can be stored on the SaaS, so that way if you have an organization or a team on our SaaS, they can work with that stack independently, and we can serialize those updates to make sure changes aren't being stomped on one another. However, like I said earlier, you can manage that state file independent of the Pulumi SaaS using a local file system, or using a blob storage, such as if you have object storage on DigitalOcean or any other provider for that matter, we support that as well. But then the onus is on you to make sure that state is managed appropriately, it's locked, and that you are sharing it with your team. If that's not something you want to take on, but you still are wanting to manage the state yourself, we do have the ability to host our Pulumi SaaS in your infrastructure in the cloud on-prem. We can ship you an artifact, whether that be a container or a VM, and you can run this independently. You can work with us in our folks to get you into a state where you're not having to reinvent how you manage the state management aspects of this if you don't want to use a default SaaS.
All right, folks, we've got time for one more question, so type them in the chat box before we run away. What are problems people don't think about when people first start working with Kubernetes?
Yeah, it's a great question. I would say the things that folks don't really think about is that it's more of a learning curve than anything. The concepts aren't necessarily new or novel, right? There's only so many ways you can set up 12-factor apps. There's only so much you can configure ingress, both north, south, east, and west. Those concepts are pretty applicable. The biggest things that hang people up is just the sheer complexity of how big the surface area is on the API resources. But you don't need to use all 100-something resources. You really only need to live with really the top 5, and that'll get you 80% of the way. So I would say focus on the typicals: the deployments, service, a config map, a secret, and an ingress object. That right there should be no more than the first couple of experiments that you run, and really helps you kind of get familiar with that. Don't try to tighten up the hatchets on security too much at the beginning. It's definitely important. There's plenty of constructs to help you out with that to make it easier. There's great documentation and resources all over the web now that help you provision, secure, ready Kubernetes clusters, and Pulumi can certainly help with that. But really, you should minimize the amount of focus on Kubernetes because there's a lot of noise. It's a big, bustling, growing project, and it aims to do a lot, but that doesn't mean you have to use all of it. So pick the resources that mean the most to you, stick to those, and just get comfortable in that wheelhouse, and I guarantee you'll be successful.
Wonderful. Thank you, Mike, for sharing, and thank you to everyone for tuning in. So, Mike, any parting thoughts or words of wisdom for our audience?
I would say, first off, thank you all for joining us. I know it's a lot these days for folks to take time out of their busy days to join us for an hour. So I'm thankful and I'm grateful for everyone who joined us to learn about DigitalOcean, about managing Kubernetes, and how Pulumi can help in and out around that. I encourage you, please reach out for help. We have a Kubernetes channel in our community Slack. That is the best way to interact with the team, with thousands of community members who use Pulumi, with thousands of our customers that are using Pulumi. You can get started by visiting Pulumi.com. And if you like this content, we have more content on our YouTube page. on Pulumi TV, and you can also visit DigitalOcean's YouTube channel as well, where they'll be linking this video with the tutorials that we've covered.
All right, thank you, Mike, and thank you, everyone. You're going to get a survey when you close this webinar. Please tell us how we did and what more you'd like to hear about next time. Thanks for joining us, and see you again soon.
Thanks, folks.
Bye.
Have a great day.